Last night we introduced you to a new chapter called Statistics, and we said it's basically methods of collecting and analyzing data, and it's very, very useful in the real world. And there's just every major company pays a lot of money for statisticians, and they're very, very useful. So today we're going to take it a step further. After we talked about yesterday was a lot of measures of central tendency and different types of studies and stuff. Today we're going to tackle some methods of dispersion. And basically what dispersion means, kind of a fancy word here, and we're just asking ourselves, how far spread out is the data? Okay, how far spread out excuse me, is the data? Basically what we're getting at here is you could have two different sets of data that have the same mean, but the sets of data could behave very, very differently. You could have one set that's really consistent and closely clustered together, or you could have another set that's really spread out and random in that they both still have the same mean. One of the big things we're going to look at today is typically, in most cases, the smaller the number, the better, because the smaller the number, the more consistent the data is, and a lot of times we want our data to be consistent because the more consistent it is, the better our predictions will become. But today we're going to look at three different methods. The first one is range, and that's the method that comes straight out of third grade. Basically, you're going to take the maximum value in the set, you're going to subtract the minimum value, and that's your range. The two real new ones are, we're going to introduce you to something called standard deviation. Whoops, trouble spelling here. Standard deviation, and we're going to look at two different types. We're going to look at a population and a sample standard deviation, and then the same thing goes for our third one. We're going to look at variance, and there will be two types of variance, one being sample and one being population. All right, here's a unique problem, and they didn't necessarily give us the context of the question. When we look at the data here, we don't know what the 100 represents, but we do know that that data number occurred 8 times. For whatever, we could pretend that these are test scores, or whatever. And so there's 8 people that had 100. Maybe there was, the score was on a scale of 0 to 300 or whatever. 15 people had a score of 150. 21 students had a score of 200, et cetera, et cetera. Now, what we're going to do is we're just going to find the range, and we already defined range as the maximum value minus the minimum value. So with regards to that, the frequencies are irrelevant. It doesn't matter how many people had each score. It has nothing to do with the range. We're going to take our largest number, we're going to subtract our smallest number, and there you go. There's your range, 200. And again, we're measuring dispersion. We're measuring how spread out the data is. Before we go on to the next two forms, the standard deviation and the variance, we need to have a kind of a sidebar discussion here on the population versus a sample size. And again, we're not going to write down the whole thing, so don't panic on me. There's just more here in case you're interested in doing more reading. But basically, here's what I want you to get in your notebook. The population form is used when the data being analyzed includes the entire set. And in your notebook, I want you to emphasize entire set. That's the real buzzword there for population. Then we come over here. A sample form is used when the data is a random sample taken from an entire set. So it's kind of like a subset. So tell yourself a sample, think of a sample as a subset, whereas the population represents the entire set. One more quick note here. I want you to, by default, by default use population form. We're going to use population probably 95% of the time. And if there's not enough information to tell whether you should use population or sample for whatever reason, just by default go to population. Standard deviation is kind of a really interesting concept that I've fallen in love with over the years. Now, as far as your job on the quizzes and tests, it's going to be very easy, to be honest with you. We're gonna throw the data into our calculator, our list 1, list 2, and we're going to hit a few magic buttons and let the calculator do the work. But as your teacher, I'd like you to have an appreciation for what the standard deviation is measuring. Again, it's measuring dispersion. It's telling us how far spread out the data is. The smaller the number, the more consistent the data is. And my favorite definition, I've looked at a lot of different definitions for standard deviation, and here's my favorite one. It says it's a mathematical formula for the average distance from the average, okay? Or you could replace that word with mean. So it's the average distance from the mean. So here's my picture here. I've got a kind of a goofy looking picture. We've taken 5 dogs of varying sizes. We've measured their height at their front shoulder. And that's what these little red lines represent here. They're measuring the height. What we're going to do here is we're going to find the average or the mean height. And you'll see this beautiful green line right down the middle. That's the average height of the 5 dogs. So what the standard deviation is doing is it's measuring the average distance from, you take each data, you ask yourself, how far is this set from the average? And then the same thing with this guy, and the same thing, even though this one's below, and this one's slightly above, and this one's slightly below. You take the 5 differences between their heights and the average, and you kind of average those numbers together. And so the standard deviation is a real interesting tool. Well, I kind of hinted earlier that there's 2 different kinds of standard deviations. The one that we're going to use by far more than the other is what's called the population standard deviation, and I'll show you how to get that in your calculator here shortly. This is a weird Greek letter. That symbol that I just wrote on the paper here is a lowercase sigma. Okay, it's a Greek letter with a subscript x. You can practice writing that a few times. It's just kind of got a little, it's like an O with a little squirrely thing at the top. And that's as I said, that's a lowercase sigma. Now you're wondering, well, what's an uppercase sigma? Hopefully you remember uppercase sigma is that summation sign we used earlier. Okay, now the other word or notation you'll see, you're going to see a capital S with a subscript x, and that's called the sample standard deviation. So if we kind of have a subset and find his standard deviation, then that would be a sample standard deviation. But if you stick with the entire set, which we typically will, it'll be population. Okay, variance is our third form of measuring dispersion today. It's very closely associated with the one we just finished. There's 2 types again. Again, the more popular one's going to be population. And again, popular, population, both start the same way. So that's how you can remember which one to use more often. Population variance, all we're going to do is we're going to take the standard deviation you found 2 seconds ago and raise it to the 2nd power. You're going to square it basically. Or if you wanted the sample variance for some reason, what we're going to do is we're going to take our, let's see here, we're going to take our sample standard deviation and square that. So that's all it is. It's just, again, measuring dispersion, how far spread out the data is. We're going to take our standard deviations, which the calculator does for us, and then we have to square it on our own. Okay, I want to reintroduce you to the same problem we saw just a few minutes ago when we did the range part already. So we can cross that off. We already covered that. We want to tackle the standard deviation. Whoops, there we go. And then the variance. We're going to round our answers to the nearest hundred, so we're looking for 2 decimal places. We'll make a note to ourselves there. Now, and then here's a key note here to kind of help you get used to this. Since the question deals with the complete set, the entire set, we're going to use the population form. And so just a quick recap from yesterday. Hopefully your calculator skills are feeling good. We're going to put the data into L1. We're going to put the frequencies into L2. Once we do that, we're going to go to the stat calc menu. We're looking for one variable stat. Before you hit enter, we're going to type in L1, comma, L2. We have to explicitly tell the calculator to look in those 2 lists. He'll automatically know that the list 2 is for frequencies. We hit enter, and I'm going to go import what my calculator looks like right now. So here we go. Here's what my calculator looks like now. I used a different calculator today that was fully updated, and so maybe some of you were scratching your head in last night's video looking at when you do your one variable stats. I got a slightly different menu here today. For the list, I just specified L1. For the frequencies, I told the calculator to look in L2, and then I highlighted the calculate word here and just hit enter. Once I did that, it spit out the same list we saw yesterday. That first number is the mean, in case they ask for that. And here's the 2 new symbols today. The S stands for sample, and the lowercase sigma here is for your population. That's the one we want. So we're going to go ahead and we're going to say that our population standard deviation is, we're going 2 decimals, I believe, 56.42. And remember, the smaller the number, the better. That means the more consistent it is. And once you get a number of problems under your belt, you'll be able to have a good feel for what is small and what is large, basically. The other thing is variance, and we're going to show you a real neat trick on the calculator here. All right. So what we want to do is I want you to find the vars button right here. It's just to the left of the clear button. And once you hit the vars button, it'll take you to a menu that looks like this. Okay, we want to go to actually number 5 here, statistics. Just hit 5. That'll then take you to this menu, and what you'll see there in choice 4 is that fancy little lowercase sigma we want. So hit 4. We're going to go back to the home screen, and you got to still do one more thing. You got to type in the squared button. Then you can hit enter. You should see this number right here. So we're going to say 3,183.42 is our population variance rounded to the nearest hundredth. Okay, we've covered all of our definitions and such today. We've introduced you to most of the calculator steps. So now we're going to just crank through a bunch of examples that you could possibly see on our upcoming test. And you'll notice the question is about comparing. Whoa, get that pen. Okay, here's the pen. Grab the right thing. All right, it's all about comparing the range to certain other things. And so the range is kind of the common theme in all of these. And remember, you don't need the calculator for range. We're just going to take the maximum value, then subtract the smallest minimum value, and we got an answer of 6. So we know that our range is 6. Now I am going to use the calculator for the rest, and I'm going to put my class size in L1, my frequencies as always in L2. Be careful. What we're going to do is take the numbers you just put in there. How are we going to get rid of them? We're going to highlight the L1. We're going to hit clear, enter, and then type in the 8, the 10, and the 14. Then go back, highlight the L2, hit clear, not delete, enter, and then type in the 1, the 3, and the 2. Run your one variable stat. Here's what I got. I got an X bar, also known as mean, of 11. And I got a standard deviation, population anyway, of 2.236. So let's go through the choices one at a time. Number 1, does the range equal the mean? No siree. Number 2, is the range bigger than the mean? Again, 6 is not greater than 11, so we'll cross that off. Is the range smaller than the mean? Yes, I like that one. Just to make sure, the last one at 4 here, is the range smaller than the standard deviation? No, 6 is not smaller than 2.23, so we'll cross that one off. Okay, on a lot of these problems, I'm going to need you to exercise a great deal of self-discipline. Otherwise, you're going to be a little uncomfortable tomorrow in class as far as the speed of everything. So really practice those calculator steps. Now, I need you to hit the pause button. I need you to be diligent about typing in all the quarter averages here into L1, and then we'll push the frequencies here into L2. Then you can run your one variable stats and see if you can answer this question about population variance all on your own. Okay, now one thing here, and the great John Wooden was perhaps arguably the greatest coach of all time. He was a basketball coach at UCLA in the 60s, 70s, and so forth. And he had this famous quote. He said, "Be quick, but don't hurry." And think about that little brain teaser for a little bit. But anyway, and I think that applies here because we want to get this data typed in as fast as we can. But at the same time, if we just mistype one single number, it's going to screw up all of our calculations and throw everything out the window. So get it in there as quick as you can without making any careless mistakes. Make sure, another good trick is to make sure you have, when you're all done, make sure you have the same amount of entries into each list. That'll be a good indication of whether you missed one or not. When I ran my data, I had a population standard deviation of 8.2-ish. So I've got to now I've got to go to the variable menu. Once I get to the VARS menu, I'm going to choose choice 5, statistics, and then choice 4 there is your lowercase sigma. Hit that. Then don't forget to square it, and you should end up with 67.311. The nice thing is that you don't have to worry about storing anything. That standard deviation, all of its infinite decimals are already stored in that lowercase sigma. Here's one of my very favorite questions, and I think it really focuses not on the number crunching ability, but on your conceptual understanding of standard deviation. And remember, standard deviation measures dispersion and how far spread out the scores are. So here's what's cooking. We got Gene's math scores here. 98, 97, 99, 98, 96, and then their scores on their 5 English tests are as follows, okay? Which statement is true about their standard deviations? Now, before you even look at the choices, and you could try to cover up the 4 choices, what I noticed is that her math scores were way more consistent, okay? Which means we're going to have a smaller standard deviation. However, her English scores are a little more random and sporadic. So, we got as low as a 72, as high as a 95. So they're pretty well spread out. And so we're going to have a higher standard deviation on the English scores. But anyway, let's scan the choices here, see which one you like. If I'm going too fast, just hit the pause button. I like number one perhaps. It says the standard deviation for English is higher or greater than the standard deviation for math, and that's spot on right there. Here's a sneaky one to type in. I've seen a lot of students get kind of mystified by this one, but we're talking, the table describes the winning times in the women's 400-meter freestyle swimming event at the Olympics. Okay, so in the year 1960, the winning time was 4.66, and in 1964, the winning time was 4.73, etc., etc. Now, here's the deal. We need to plug these into the calculator somehow to get the standard deviation. And what I've seen in the past is I've seen a lot of students put the years in L1 and the times in L2, and that's a tremendous mistake, okay? The years really have nothing to do with this problem, believe it or not. Now remember, the only time we put things in L2 is if we have a frequency, you know, like if a number of people had the same time. So what we've got here, all right, the times are going to go in L1, and then that's it. That's all we're going to put is the times in L1, and then when we do our one variable stat, we're just going to do L1. We're not going to type in L2. There are no frequencies, okay? So let's try typing this in and see if you get the same data I get. So just a quick recap. When I had to delete the L2, the calculator kind of had the L2 in there already when I did the one variable stat on my updated version of the calculator. So I had to delete that L2. And then I got, and here's how you know you did it right. If look at the bottom of your screen and you see an n value. If your n value is equal to 8, then you know you did it right. Now my standard deviation, again we're looking for the population version by default, was 0.24. And again we're looking for nearest hundredths, so we got 2 decimals here, and that's it. Okay, we're creeping up into the more challenging ones. We've got like 3 problems left, and they definitely have an extra added twist. Instead of being like a multiple choice question, these are now more of like a part 3 caliber question on the exam. So we got 6 golfers had the following scores on 9 holes of golf. What we're going to do is I want you to take these scores, and we're going to enter these scores into L1, okay? And then we're going to leave L2 completely empty. There are no frequencies. And then I want you to run that list, and I want you to calculate the standard deviation to the nearest tenth, okay? And then once we get there, let's reconvene, and we'll talk about how we're going to handle the second half of this question worded right here. Okay, first in blue, the standard deviation, again, I had to leave the L2s empty. My standard deviation was 3.83. Well, we go nearest tenth. Let's just call it 3.8 was my standard deviation. Now in red, there's a second question. How many of those scores were within 1 standard deviation of the mean? Now I know this is a totally new question for us. I want you to construct a thing that kind of looks like a number line. Right in the middle of that number line, we're going to put X bar. That's our mean. And on my calculator screen, my calculator is telling me it's 43 right now. What we're going to do is we're going to go 1 standard deviation above, and then we're going to go 1 standard deviation below. And kind of create an interval, a lower bound and an upper bound. Okay, now, so if I do, let's label this. I want to see really, really good notation tomorrow. Let's call it mean plus the standard deviation, 43 plus 3.8. That's 46.8. All right. And then on the lower end, we're going to do the mean minus the standard deviation. So 43 minus 3.8, that's going to be like what, 39.2, I believe? Okay. Last thing we got to do, we got to go through this list right here and count how many of those numbers fall between 39.2 and 46.8. I'm going to say 38 is too small. 38 is too small. 43 is good. 45 is good. 46 is good. And then 48 is too large. So how many of the scores? I'm going to say 3 scores total fall within 1 standard deviation of the mean in this gap right there. Here's an awesome example, and they're talking about Mel taking 12 tests in sequential math 3, which is kind of the old name of the course that we're in currently right now. Oh, anyway, they reserve the following grades. And I'll tell you what I recommend is we just take them all, we put them all into L1, one at a time. You could do, like for instance, you could use frequencies here. Like you could type the 89 once into L1, and then just do a frequency of 3. And then you could type in the 90 one time and do a frequency of 3, and you could type in the 92 once and do a frequency of 2, so forth and so forth. But I think that's more hassle, perhaps. I just type them all in at once. Go ahead, hit the pause button, do that, and then let's come back and compare our numbers. All right, to the nearest tenth on my standard deviation, again, we're going population unless they say otherwise. I have 3.9 to the nearest tenth. It was 3.88. Make sure you're looking at the right one. The sample's 4.056, and so don't look at that one. Look at just the lowercase sigma. Now here's the real question that I want to get at here. What percent of these test grades are more than one standard deviation above the mean? Above, again, above. So here's my number line, right? Now, last question we did within one standard deviation, so we went one below, one above. But this time, let's put your average on 91.5. Let's go one standard deviation above. So we'll do mean plus lowercase sigma, that's 91.5 plus the 3.9 for a grand total of 95.4, I believe, if I did some mental math correct. Feel free to type that into your calculator if you need to. So here's the deal. We got 95.4. Let's go down the list. We want to know how many numbers are more than that 95.4 number. And let's see what we got here. Let's see. Too small, too small, too small, too small, too small, too small, too small. We're getting a little warmer. Too small, too small. Boom, there it is. 1, 2, 3. There was 3 numbers that were bigger, more than one standard deviation above the mean, and we still haven't answered the question. We want to know what percentage of the scores. Now, how many scores were there total? You can either count them one by one, or you could look at your calculator. The n value is 12. So what I'm going to say is I'm going to say 3 out of the 12 scores. If we do 3 divided by 12 on our calculator, we're going to get 25%. Now, your calculator shows 0.25. Move the decimal twice. 25% of the scores are more than one standard deviation above the mean. That's the percentage that lies up there. All right, congratulations. You survived all the way to the last slide here. Mr. Koziel had 17 students in his high school golf club. Each student played 1 round of golf, and the summarized scores of the students are listed below. Now, we do have frequencies here, scores and frequencies. Scores are going to get entered into L1. Frequencies are going to get entered into L2. We haven't used L2 in a few problems here. Here's what I'm going to have you do on your own, and this is going to be something we check in the notebook tomorrow. I want you to find the population standard deviation on your own, all right, to the nearest tenth. So we're looking for lowercase sigma there. And then I want you to tell me how many of those individual students' golf scores fall within one population standard deviation of the mean. So there's where you're going to create your number line. You're going to put your mean in the middle. You're going to go mean plus a standard deviation up here. You're going to do a mean minus a standard deviation down there, and count how many of the scores fall within. Now remember, if 80 falls within that interval, you got to count that number 3 different times. So add up those frequencies there at the end. So I'll check you tomorrow and see how we're doing.